Pause it and I'll turn on the air. You're going to look at variation. This is two lessons. Whatever we don't finish is going to be for homework. So,
Chapter.
tons. We're actually even skipping one. 10? There's 10? Okay. So we're going to look at variation. It describes how the data is spread out. In order to do the normal distribution curve in the next class that we're going to have, you have to first find your standard deviation. How much something deviates from the mean. Okay, that's really all it means. How far is it from the mean kind of thing. So there's these steps into finding the standard deviation. And the first thing, I want to go over what some of these little symbols are. It's not hard. I just want to explain what some of these are. You find the mean first. They use this X with a bar over it. So when you get into college, if you take statistics, they might use that little symbol. I'll probably just tell you to find the mean. But in college, they're going to use this symbol, X with the bar over it. That means you find the mean. Then you take the difference between each value and the mean. Your calculator will also do this for you, and I'll teach you that later. All right? But because sometimes in college, I remember they gave us this table, this chart that we had to fill out each little thing. I took two. If you're in business, there's a business statistics, and if you ever do a master's and you have research, you also have a statistics in that. Anyway, then you take each of those differences and you square them. And then you find the average of all those numbers. Add them up and divide. Remember that little sum thing? It just means you would add up all those numbers and then you divide by how many there are. All right, and they use this little symbol for variance. Again, in a little while, I'll show you on your calculator. Your calculator is going to use some of these symbols, so it would give you your answers. Then you take the square root of your variance, and that's your standard deviation. That's all you have to do. But none of it's hard. It's just step by step. Okay, so what's your first step? What do you have to do? Find your average. Okay, so let's look at a problem. And they want us to find the variance and then the standard deviation. Again, the variance is just before you take the square root. And then the standard deviation is when you square root it. All right, then I'll tell you what all that means in a little bit. So they just start with a few numbers. They start with, okay, here's our numbers, 6.9, 8.7, 7.6, 4.8, and 9.0. And I'll kind of show you how they make a little chart. These are all of our X values, okay? Then the next thing they want us to identify is the mean. Remember I said they use this X bar. How do I find the mean? I would what? Add up all these numbers and divide by how many there are. So let's do that. Oh, I told you I'd give you a calculator too. Take out your calculator, add it up, and y'all are going to have to give me the answers because all my calculators are gone. Add them up, divide, and tell me what your mean is. And that's my answer. I'm going to put it in for all these. Add these up, divide by 1, 2, 3, 4, 5.
I got
7.4.
7.4. That could be wrong.
Nope, that is correct. So I'm going to put, that's my average, my 7.4 for all of them. Yeah.
When we get a second, can I play around with my truck?
For?
I have to get those raffle tickets turned in.
I would wait until after class because they're not due until Friday, I don't think. Okay. Now, the next part is it wants us to subtract our X value and our mean. So we take our X value and subtract the average for each of these. So I would just do 6.9 minus 7.4.
So they're all 7.4?
Yeah, the average is 7.4. They just do it in a table so you can see step by step. You have your X values, you find their average, now we subtract them. Next thing we do is square them, and then we add them all up, and that's it. Okay? I mean, it's a lot of steps, but all right. What is 6.9 minus 7.4? Negative 0.5. So do y'all see what I'm doing? I'm just subtracting. Negatives and positives it doesn't really matter because what happens when I square it? Yeah, so I'm just going to write down my answer, but it being negative is not going to mess up anything because in a second, I just subtracted those. I know I went fast, but does everybody understand what I did there? Yeah? Now, we square all those numbers. They write it on their table like this. I just don't want it to confuse you. But all that means is they took each of these numbers and they squared it.
So -1 or
Well, it would be 0.5 squared, isn't that 0.25?
sure.
Yeah, not times 2, but you square it. So 0,
5 times 7.
yeah, 0.25. Then what? 1.69, 0.04, 6.76.
Okay, so are you doing this on your calculator?
2.56.
A little fast.
I don't have a calculator. I just have a book.
Oh, that's cheating. Can I use my book?
Yeah, you can grab a book.
Like here?
But you can really grab a book if you want to, but does everybody understand where we got these? I just squared these numbers. Then, you might not remember from the beginning, but I said, then we add them all up and divide by how many there are. So let's add them up. If I add
So am I adding every single number?
all these right here in this column, we add them up and let's put our total right here.
What, you added the last 2 columns?
Yeah, just add up this
Oh.
column. This is to tell us the standard deviation, which is what we're going to use in 2 lessons. Okay, we have to find this, and I'm going to make it faster, but there may be a problem on your test where you have to fill out a chart like this. So you need to know how to do it.
2.26.
Okay, did everybody get, okay, well, you got 11.30, and then he's right. Then what did he do? He divided it by 5, and he got 2.26. Now, that is our variance. That's what this means. They do this little Greek letter. So in a little while, when your calculator does this, it's going to give you your variance, okay? Now, how do you find the standard deviation? What's that last step I told you we would do? We would square root it. That's your standard deviation. So our standard deviation, what's the square root of 2.26? 1.5. Okay, which today, that might not mean a whole lot to you, but I promise in 2 lessons it will.
Okay.
Like, this will all
Let me shorten that book.
I know, always. This will all come together when we do our normal curve. Do y'all even know what a normal curve is?
Not a clue.
A bell curve?
Not a clue.
Have y'all ever heard of the bell curve?
Not a clue.
When people grade your tests and stuff and they say the bell curve, this is a bell curve. This is what you do in statistics. So most of the time when you have a bell curve, the majority of your data should be right here. So there should be a few people with A's, a whole lot of people with B, C's, and D's, and only very few with F's. And whatever kind of thing you do, that's how all the scores should fall. It's not usually like always that way, but that's a bell curve. We can take any data and we can put it on a bell curve and know where, like what percentage of what should fall. We have to know the standard deviation to do that. So today we're learning what the standard deviation is, okay? Because then I could see how far away it is from my average. We'll get into it. Let me play. What I'm going to get you to do is number 2 and 4. Then I'm going to show you how to do this on the calculator. But I'll leave this up here, and if you need me to explain anything, this is exactly what you're going to do. You're going to write this out, okay? Your x, your average, you subtract, you square it, you add it up, you average it, and you square root it, okay? So 2 and 4. I know y'all are working hard. So I'm going to do number 5, and you're going to do number 6. Y'all are actually going to write both of them on the paper so you get credit for each. So 2, 4, 5, and 6. Can I borrow someone's calculator who would be?
Here.
Take it off my hand.
Here.
That's a further off. Take it
Look
off.
at this. This is insane.
Okay. But are you paying attention so you can do number 6?
Sure.
Because y'all are going to do number 6 using the calculator.
Why are you sending out beta notifications there in class?
Because I was asked. Okay, now what you can do is find the standard deviation using your calculator. You can also find the variance from there if that's what it asked for. So notice they said they want our mean and standard deviation. This is all my data. There's 12 numbers, okay? Since we're doing statistics, guess what button we press?
Statistics.
Stat. for statistics. And I'm going to go in and I'm going to go to edit. Now, if you have a bunch of stuff, you can delete each one, but I'm actually going to go back to stat, and I think I can clear my list. Oops. Sometimes it says error.
Quit or go to.
I don't know why it does that.
Oh my, you just internalized
This made my calculator do that thing again.
Okay, I'll figure. Okay, I might just go to setup editor and press that. Now let me go see. It's still there. Just press delete then. I don't know why I can't ever clear a list. Okay, I'm just deleting it. All right. You can't press clear. You must press delete. So I think you just need to. You go to this. Do the same thing I just did. Look, Riley Kate. Whenever you mess it up like that, you just press stat. Go to setup editor. It's kind of like it takes it and it restores it back to normal. Like when I go to edit now. See, and you'll just have to delete all those. Okay? You're welcome. All right, now what am I going to do with my list 1? I'm going to enter in all these numbers on number 5. Okay? So I've got 5.34. Yeah, no, all 12 numbers. This is just a list of data.
All 5, it's like order you go.
No, it doesn't matter. Boys, are y'all listening? Entering in? 5.4. 5.41, 5.42, 5.5, 5.55, 5.55 again, 5.57, no, 5.7, I mean, not if it's at the end, 5.65, 5.66, and 5.68. So we have 12 numbers that we put in list 1. Then I'm going to tell it to do something, okay?
I have 13 too.
I think I did 5.
No, your 13's on your blank. Is it blank? There should be 12 numbers.
I got 12 now. I did one more.
Wait,
Let me go back and check them.
yours, I think your thing was just in your blank space, like she said. Oh my god.
Okay.
All right. Does everybody get this?
No,
Just stat,
I'm good.
edit, put your numbers in. Now what are we going to do with these numbers? We're going to calculate something, right? So we're going to press our stat button. Is everybody with me? And go over to calculate. We only have one thing of data. It's just one variable statistics. It's the first thing up there. Okay? So I'm going to press number 1. All right? And I'm thinking
Mine does not say that.
that's all we need. Just go down to calculate. So it should have list 1 right there, and that's what you put your numbers in. And if I go to calculate, look at all this information. You just have to know what everything is. Look at that X with the bar over that. What is that?
Okay, yeah, his does do that. Is there a way you can do it like this?
So you should just press enter, right? Does it?
Like that?
Yeah, so it should give you the same thing. Remember, the X with the bar is the average. Notice on number 5, what's the first thing it asks for? Find the mean. All right? Find the mean. That's the average. So I can write what? 5.5. I've already found, my calculator did my average for me.
Hey, why do I have different numbers?
Did y'all get the same number?
Mine says 5.544166.
Did you put all the same number? Did anybody else say something different than mine? No, you might have put like just one little number in wrong. Okay.
This is not going to pull my hair out my head.
Now, the standard deviation is actually this number right here, 0.117. Okay? So I would probably put 0.12. That's my standard deviation. Because the variance is that squared. So that's your standard deviation. I wanted y'all, let me make sure, but I know that's, what number is this? Number 5? They put 0.12. I said I would put
0.12.
0.12. Okay, yeah. I would put 0.12. I would just I'd round it.
Not hot.
Okay?
It's burning up in here.
I've got the air on.
Is that
I'll turn it down some. That's it. So y'all are going to do number 6. Denver, let me give you your calculator back.
Are you adding it?
I was trying to go, okay?
You wish. I'm blushing.
Number 6. Y'all try. Then we're gonna do our last problem.
We do. I don't remember how to do
Our
it.
last lesson or last problem?
For this worksheet, we'll do our last problem. Do number 6. Let's look at number 7. All right, number 7. Do they want us to? Well, we're gonna draw one of these things. All right, what numbers do we see on number 7? Shh, y'all be quiet. From what kind of numbers? It looks like 62 all the way to what? 72. So I'm just going to go from 60 and I'm going to count by 2s. I'm just doing a little number line, right? 70. What did I say? It goes up to 72. I'll go to 74. So I'm just going to put an X on 62, on 63, on 65. See how I'm just doing my data? I have 2 X's on 64, 2 X's on 68, 69, 72, and 66. Does everybody see where I put an X for every time it was on that number? Like 64 and 68 have 2 X's. This is called, do they say what this is called? I forget.
How did you figure that out? Where did you?
Good aim.
I'm confused.
What?
Where'd you go with X's?
I just put an X. I'm trying to see what they call this. I know there's an. Hold on. I don't know what they call this chart. We'll just call it an X chart. All the X's mean, you're looking at your data on number 7. How many times do I have the number 62? Once. 63, once. 64, twice. And so on. Now, what I have to do is find the mean. Well, actually, I don't. It says, how many standard deviations? It says the hours students in your study group study is 66.1 minutes. Okay, that's your average. 66.1. Where is that at on my chart? Right here at 66.1. Does everybody see that? This is my average, 66.1. It told me that in my problem. It told me that's my mean. How many standard deviations is the standard deviation is 2.9 minutes. How many times will I go over 2.9 before all my data is included? So somebody tell me, what is 66.1 plus 2.9? And somebody else find 66.1 minus 2.9. We have to go both directions.
Minus 2.9 is 63.2.
Okay, so here's about 63.2.
Do I need to put that on here?
Yeah, I am. Watch. I'm putting, that's one standard deviation. And what was when I added my 2?
69.
Okay. Right here. Now, that's from here, I went out 1 standard deviation. Does that include all my data within that? No. So my answer is not 1. Guess what I have to do again? I need to add and subtract 2.9 again to see then if it includes all my data. So what's 69 plus 2.9?
Wait, did you just add those two together?
Wait, say that one more again.
Okay, so I didn't include all my data. I went out 2.9 in both directions. It didn't include all my numbers. So guess what I have to, this was 1 standard deviation. So I'm going to have to go again. So what is 69 plus 2.9? 71.9. That's right here. Okay, that was 2 standard deviations. Now what was 63.2 minus 2.9? 60.3, about right there. Okay.
Where did
I'm gonna need
get?
Now, all right, they told me my mean. They told me my mean. That's my starting point. Then they told me my standard deviation is 2.9. So all I'm doing is adding and subtracting it. When I add and subtract it, I go to here and here. Does that include all my data? No. I went out 1 standard deviation. It did not include all my data. So I'm going to add and subtract the the standard deviation of 2.9 again. When I do that, does that include all my data?
Yes.
Look at that little X at 72. Did I include it? No. So guess what I have to do again? I have to go out one more standard deviation. Is that?
Both sides?
Yeah, it goes both ways.
Oh my goodness.
But listen, I don't have to find the numbers. Is that one going to include it this
Yeah,
time?
so it's only three.
So it's going to be 3. My answer is 3. I had to go out from that number 3 standard deviations before it included all of my data. That's what it's asking. So your answer is just 3. All right?
Okay.
Yes, I already told you yes.
Oh.
It was just in the middle. Like, I just keep
Yeah,
going.
yeah.
I was like, yes. So then what do we,
Gotcha.
I just kept going.
I don't think.
Where did the 60.3 come from?
Y'all are going to do the 60.3. I subtract 63.2 and I subtracted 2.9. Yeah, you're either adding or subtracting. Now,
Oh,
let me do number 9 with y'all,
Shut up.
and then y'all are going to do number 8.
Wait, why'd you subtract the 2 point whatever?
You have to add or subtract it. Both. You have to add and subtract it. You start at your mean, and you add and subtract. You have to go both ways. Your data goes both ways. When you're in the middle, your data doesn't go up or just down. Your data goes where? If you start in the middle of it, it goes both up and down. So that's why you have to add and subtract that standard deviation. And that's one time. When you start in the middle and you add and subtract, you went out one time. Add and subtract again 2 times. Add and subtract again, you went out 3 times.
How do you know what to subtract?
They told us on that one. It was in the problem. On number 8, you're going to do, they tell you those numbers as well. But look, do y'all want me to do number 9 for one more practice? Okay. I'm going to do number 9, and then y'all are going to do number 8. 9's a little harder. I do, but that's why I'm doing it and you're not. Okay, number 9.
Can I just watch you do this?
Yeah, y'all can just watch number 9. Number 8's actually easier. Number 8, you just do the same thing. They give you the average, and they give you the standard deviation. Number 9, it says, use this data that's during the past 10 months, find the mean and standard deviation, and then it says how many items fall within 1 standard deviation. How many items fall within 2. So I'm going to have to draw my little line, and I'm going to put all my numbers. And they range from 113 to 545. So I'm probably going to count by, I think I might do 25s. I may do, no, I might count by 50s. 100, 150, 200, 250, 300, 350, 400, 450, 500, and 550. Okay, so now, and I'm looking again at number 9, 124. That's about right here. 113. That's about right there. 152. 545.
So you just put X's.
I'm just putting X's about where they go. 150. Oh, actually, that one should have gone right there. 490. 442. 207. 124. Again. Right there. And 147. That one is right there. Okay, so I don't know my mean on this one. So I just put X's where they need to go. And I need to find my mean and my standard deviation. How would I do that?
Add them all up.
Well, so I'm going to enter my data in my calculator.
Yeah.
And I would let it tell me. Okay, so on this one, do y'all remember how to do that? I'm just going to tell y'all what it is. But let me look at number 9. It says my mean is 249.4. If I was to have found it using my calculator, my mean is 249.4, and my standard deviation is 162.5. 162.5. So what I'm going to do is I'm going to start at 249.4. That's about right here. Right? That's my mean. That's my average. Well, I would have just put all that data, all those numbers in my list, and then press the calculate button.
Do you put the numbers on the number line or the numbers that they give you?
The numbers that they give me. Yeah, so I would put all these numbers right here, 124, 113, 152 in list 1. Then I would have calculated, and it would have told me, hey, your mean is this, your standard deviation is this. So I found my mean, 249.4. Now, let's see. It says how many items fall within one standard deviation. So let me go over. This is the only calculator I have. 249.4 plus 160. Let me do that. 249.4 plus 162.5. And I get 411.9. Did any of those? Not that way. They didn't fall. But then I also have to go to the what? The other way. So I'm going to take my 249.4 and subtract 162.5. And I get 86.9. That's way over here. So how much of my data fell within that mean? 1, 2, 3, 4, 5, 6, 7. That's what it's asking. 7 items fell, within that standard deviation from the mean. Okay?
I forgot how to find your standard deviation.
They didn't fall within it. Now, if I went out 2 standard deviations, hold on. If I went out another 162, let's see, I started.
Or why do you go out again?
Well, it says on the next part, if I went 2 standard deviations, does all my data fall within the mean? So I'm going to see. So I'm going to add 162.5 again, and it goes to 574. So what would I say?
Yes.
All of my data is within 2 standard deviations. Okay?
How do you find standard deviation, whatever?
Do the deviation, you go to your list. You go to stat list.
No, I'm trying to do it up here. But what do I?
What do you mean? Oh, at the top?
Yeah.
Did you do your average and then you subtracted? Then did you square it and you added it up and you divided by 12? And so you got your variance when you divide by 12. Now square root it.
Okay,
And that's your standard deviation.
But
Yeah.
so we could enter it on here.
Yeah, so now there may be one where you have to do that, but then yeah, you can just do that on there. So you're doing number 8, but you don't have to enter anything in on your calculator. Number 8 tells you what's your average. 18.25. And what's your standard deviation? 30.1. So how many times do you have to go out from your average
Do I just
before?
enter in those numbers like on the line?
Yeah,
Or do I
0.25,
do-
0.25,
I have
6,
to do
8.
other numbers.
10, those are the numbers on your line. On number 8, those.
How would what
Okay,
would
so
you
it's number
count
8
by?
3.
I would actually on number 8, I would count by
Is it 3?
tens probably.
Is it 3?
Let me look.
It's like 5.
I would count by 10, 20, 30. Yes.
Can I go to the potty?
Huh?
Can I start at 0?
Yeah, I would start at 0 and I would just count by tens
So all the way
to 90. Yeah, I would just count by tens to 90. So some of them are going to be, there's going to be 5 numbers really close together, really low, right? And then 1 number way up there. And then you have to find your average, draw the line, the dotted line through the average.
Who's on my printer?
Oh no, I'm sorry. Sydney told me that might happen. I thought, because she has the same number. And so, okay, thank you. So when you find your mean, draw a dotted line in the middle, and then, so,
How do you find your mean? Is it 30? No. You said your mean is 18.
yeah, I would count by tens. Let me make sure I pause my video.
It says it on the board.
Oh.
Oh.
I don't find it.
So I'll just say it's about right here.
Oh, no, wrong thing. Hold on, here it is. Oh, I need to pause. Go. There's a lot of information, and I'm just going to go through it. If you're not listening, you're just going to miss it. So, A convenient sample, and y'all, this was in college algebra, not just in statistics, but I just went through college algebra with them in the spring, and it asked about samples and surveys and all this kind of stuff. It's very basic for college algebra. It gets harder in statistics class. Now, a convenient sample, what they mean by that is if you were doing research and you're going to collect data, convenient sample means you're going to go somewhere where it's convenient. Okay? Like I'm just going to go to a park and ask people that walk by. Right? That's very convenient. I don't have to walk around. Or I'm just going to go to the basketball game tonight and ask a bunch of people at one time. See how that's just convenient for me just to go to one spot, and I get all these somewhat random people depending on what I'm surveying about. If I'm doing a survey on sports and I show up at a basketball game, is that a really good place to do your survey? No, because those people, you're getting all the same type of people. People who are there for what? A sport. Okay? Now, if I was to go to, like a restaurant. Okay? I could probably go to a restaurant and stand out there and survey people about sports, right? Maybe not walk-ons, but, just some random restaurant and survey people about sports. And that would probably be a good survey to do there. But I wouldn't want to do a survey about how often do you cook at home and go to a restaurant, right? Because their answers, they're obviously not eating at home. So I could go to a park or something and do a survey there. How often do you eat at home? Anyway, convenience though is just people are conveniently there in this one area. All right. A self-selected survey, that means people volunteer. Like, hey y'all, I'm doing a survey, come by and see me. Like they volunteer to do that survey. A systematic sample, it's like I'm going to go to every third house, right? That's very random. Like I'm just going to every third house. It's systematic though. And then, but here's just a random, also can be where everybody has an equal chance, okay? Like I'll randomly flip through a phone book and pick somebody's phone number and call them. That's random. That's just, I'm kind of getting you familiar with what these words are. Your population represents everybody, like even people you aren't surveying. Your sample are the people you're surveying. They're going to represent the entire population. Like I don't want to go and ask all 50 high school students this question, but maybe I'll ask about 8 of them a question, and that'll represent all the high school students. Does that make sense? The 8 that I asked are my sample. All the high school students, that's my population. Okay. So then it says bias. Bias is what could mess up your survey. Like you don't want there to be bias. All right. So it says it's an error. And let's look at some of these questions on here before we move on.
Before we move on.
Well, yeah, I mean, there's only, how many types of questions? 3 types of questions, and we've just finished the first one. Okay? So, it says, identify the sampling method. Y'all, I just showed y'all the sampling methods, right? They were, if you want to write them down, I'll write it down. Convenience, self-selected, systematic, or random. I'll write it down right here on the side. Convenience, self-selected, systematic, or random. We're going to have to pick one which best matches our situation.
Wait, Steph, will you go back though?
Oh yeah, well I wrote them right here.
Well, I didn't know what they mean.
Convenience, well I just went over all that.
I know, but like I need to read it. Like, is that a photographic memory? So I need to read it.
Convenience, select any member of the population who are conveniently and readily available. Self-selected, select only members of the population who volunteer for the sample. Systematic, order the population in some way and select at regular intervals. Random, everybody's equally likely to be chosen. Okay? So now let's read number 1. And then it says, then identify any bias. The good news on this is you can argue your case with me. Like if this is a test question and I don't agree with you, but you put why you feel that way, most of the time I'll just give you credit for that. Okay? Like even if I'm like, I don't agree 100%, but I see where you're going with it, I'll give you credit. So a teacher committee wants to find how much time students spend reading each week. They ask students as they enter the library, what type of
Systematic.
convenience?
Systematic.
Systematic would be every third student that passed by in the hall. Okay?
But I can argue with you about
How? Not on that part,
I don't know
but
what
bias.
systematic means.
Systematic is like every 7th person in the phone book. I went to every 5th house. I stood outside and asked every other kid who walked by. Like you had a system in place. This one's convenience. I showed up at one spot, and whoever came in, that's who I asked. What's wrong with that, though? What did you...
They're asking people who are going in the library to read.
Yeah, that's there is bias. You asked people who are going into a library how much they read. Obviously, they read more than more people. Sorry, they read more than the people who are in the gym playing basketball.
You have to explain why bias?
Yeah, you will have to do that.
Do you want us to
You
do
come
it
tonight?
now?
Yeah, huh?
You coming tonight?
I'm not. I have Pekino.
You always have something to do. You know that?
I'm sorry. It's like bingo with cards, but it's different.
I thought it was called Blanco.
I don't play bunko. I play Pekino.
Okay, so
For what?
It's 2 different
Do
games.
you win money off of it?
Pekino.
No, you win give.
Pokeno. So
Oh,
there's
so you gamble.
there's
You win gives, right?
it's with a church group.
Right, okay.
You win gifts, yeah. There's like the
How much
top
money does it
3,
cost to play?
and then you can win the booby prize for if you
The what, bro?
the last place. Have y'all never heard of that?
No.
What?
So strive to get last place.
No, I really want 1st, 2nd, or 3rd, but last place isn't bad
You
either.
still get a prize?
The booby prize.
The booby prize? Is it a good prize?
It's like it's an okay prize. It's not like
Who
a
brings the prizes?
the person who hosts it. So see, I always host in the summer, so I have to provide everything. Anyway, and we're giving Christmas presents tonight too. It's our Christmas one.
Miss Casey, what am I going for tonight?
I don't know. Let's go for number 2 now, though. The students planning the junior class party want to know what kinds of pizza to buy. They ask the pizza restaurant what kinds sell the most.
Is that self?
Well, I would still say that I would say convenience. Let me see what they say. They say convenience as well. I say convenience. Now, is there any bias? I would think that would be a good idea. Like they're gonna say what sells the most, but they could say that it wouldn't match. But yeah, but they're not around them, so they need to find somebody to do a sample. Yeah, it is convenience.
We'll just start a group chat.
They said for this one, it depends on like if the restaurant sells to a bunch of older people and the kids are younger, what would kids most likely like pepperoni or cheese? But if they sell mostly to older people, then they're going to say Supreme or Meat Lovers or all that. So that could be bias there. You're just saying, that's all you're trying to do is say where could there be bias.
You remember when COVID was in there?
I do. Wasn't long ago. All right. Y'all don't really have to write all these down. I'm not taking it up. I know I told y'all that. I don't know why I said that a second ago. We're just going with it. The country road department wants to know which roads cause the most concern among residents. They ask local restaurants to hand out survey forms for customers to return by mail. So I would call that random because it's local people and it's random people. Boys, don't make me talk over you. Okay, systematic would be every third person. It's not systematic. It's
Okay, so
it could be self-selected
What's
because
self-selected again?
self-selected means they choose, like, they could just be ones to select that, yeah, I want to take the survey and hand it back. They could put that. I would pick random on this one.
It just sounds a little bizarre.
Then it says, how could there be bias on this one? Anybody have any idea?
Because
If that restaurant, it could be right by some of the bad road area, so everybody would then pick those roads. Maybe that's the only thing I could think of on that one. Okay, does everybody kind of understand what these things are? Now the last thing, because we've only got 5 minutes. So we're just going to go over this last little part. It says study methods.
Can y'all be quiet for my teacher?
I'm gonna make y'all do it for homework. Okay. The last thing is study methods. You can conduct a study to get research. All this goes with statistics. There is an observational study, a controlled experiment, or a survey. This is how you can get data. There we go. Observational. What do you think that means without even reading that? What does observational mean?
Means that we
Observe.
observe.
You observe. Yeah, you watch something that's going on. You observe members. They're not affected by the study. You're just watching them and you write down results, right? It doesn't affect anybody. What about a controlled experiment? What is that?
You have experiments and
Does that affect anybody?
Controlled.
That's going to affect someone. You can give somebody the real drug versus a placebo, right? That's your controlled experiment. You have a controlled group. You know what's going on. They don't. They don't know who got the real drug. They don't know who got the placebo. And then you want to see, and we've talked about that already in here for those that have been here. But that's a controlled experiment when you actually do an experiment. And then a survey is just when you answer questions. Y'all, if sometimes people will call you, I always tell people, and they'll be like, do you have a few minutes for a survey? I know you tend to want to say no, but they're trying to do a study on something. Maybe they have a project they're working on. Maybe it's something for the government or the state, or maybe it's something for school. They need people to respond. And sometimes when you do that, they'll pay you. I don't know if y'all have ever gotten the TV stuff before. They've mailed all the stuff and we record what we watch and when we watch, what time, what shows, all that. You're not supposed to tell when you do, or if you do that. But we've been asked several times to do it, and they pay us just to fill out the papers. Then once you start surveys, I've had somebody call me one time and I answered a bunch of questions and they sent me $7 in the mail for answering questions. It's random, but if you'll start doing that, then sometimes you get paid, sometimes you don't. They won't tell you you're getting paid.
No,
They
there's
just
ads all over social media about that.
I never knew it was real though.
I don't know on the social media. Anyway, real quick, y'all listen. It's very important though that if you can participate in them, because somebody's trying to get data for some study they're doing. All right, let's go over a few of these until the bell. What study method? Shh. And explain whether the sample statistics should be used to make a conclusion. Number 4, a company that manufactures light bulbs selects 3 bulbs manufactured each day at random. The bulbs are tested to see how many hours they last.
experiment. It's
Yeah.
called experiment.
Um,
I don't know what the other ones were. Somewhere out there.
I would
It's not a
say
survey.
I don't remember.
it's not a survey, but could it be observational? I would say it's observational, because what are you doing? Y'all listen, y'all don't talk.
You're taking those
You're
levels and observing.
You're observing what happens. So it doesn't affect anything. You observe. Are y'all paying attention or y'all chit-chatting? Okay. Observational study. Do you think that would be a good way?
I mean, sure.
Yeah, I guess if it would be enough. The only thing is, are 3 bulbs enough to represent the whole population? That'd be the only thing I would say. A food product company is researching a new artificial sweetener. Company asks 100 people at retirement home to rate the taste of a drink on a scale from 1 to 10. Half are given tea sweetened with sugar, half are given tea sweetened with artificial sweetener. Then results from the 2 groups are averaged. I would think it's an experiment.
Survey. You're taking a survey of 100
But you're also they're doing something and you're getting results from that. I would say it's an experiment. And they say a controlled experiment as well.
survey.
Okay. A high school principal wants to determine what classes students at the school would like to see added. He selects every 10th student, that is systematic, and asks them to list 3 classes that they would like. That is a survey where you're asking a question and you're answering.
Systematic survey.
Okay. Are y'all understanding this?
Yes, ma'am.
Yes. So we're
Systematic
good
survey right
with that's pretty much
That's it, this guy?
Do we keep this?
this lesson. No, y'all don't have to keep it. All we have is one lesson then midterm. I mean, we'll do our one lesson and we'll start our review after that lesson Wednesday.
When is our midterm?